Okay, example 2 here, we are going to go from an exponential form into radical form. And again, I'm going to do two problems in the same video since they're pretty short, and then I'll do some parallel examples in the next video. So we want to write these expressions in radical form. The first one, let's do negative 2y to the 4/5 power. Something to be really careful about here is what is actually to the 4/5 power. Is it the y? Is it the 2? The negative 2? Both? It's really just the y that's to the 4/5 power. Negative 2 times y to the 4/5. Well, this y to the 4/5, remember our denominator tells us the root that we're dealing with. So we have the 5th root of y. And we could put our 4th power in 2 different places. We could either write like this, or negative 2 5th root of y to the 4th power like that. Either of these answers would be perfectly fine. Okay. A lot of this section, should have warned you before, is a lot of exponent properties. And we'll practice those exponent properties a little bit in class, but it might not hurt to review those exponent properties as well. They're on page 383 of your textbook too. So I'll write that in here. Okay. Another one that we are going to write in radical form is d to the negative 3/2 power. We have a negative exponent here. So what does a negative exponent mean? A negative exponent, for example, and I'm going to come up here, x to the negative 2nd power means 1 over x squared. So that negative basically takes our base and makes it a reciprocal. So instead of being x, our base is 1 over x squared. So here, d to the negative 3/2 power, that negative exponent really makes it 1 over d to the 3/2. I'm going to write that again down here, so I just have a little bit more space to work. Now, as a radical, remember our denominator tells us the root. So we have a square root here of d to the 3rd. And I'm going to write it so my power is underneath my radical, because that's something that we're a little bit more familiar with in this case, since we have our variable expressions in there. Now, hopefully you're thinking, ah, shoot, we can't have a radical in the denominator, we need to simplify. Well, I can't square root d to the 3rd, but I could square root d to the 4th. Or you could also simplify this radical before you keep going. That might make it a little bit easier too. This d cubed under our radical, we could take a d out and still have a d underneath. So d square root of d, same thing. And that might be a little bit easier to see how to rationalize. Well, square root of d, we still can't square root, but if we multiply by square root of d, then we can work with this. 1 times the square root of d over, well, the square root of d times the square root of d is d. And d times the d that was already there is d squared. We still need to keep some of those things in mind. We don't want to have radicals in the denominator.